Hi, welcome to the lab. So, the last time we started writing a parser for regular expressions, but today we want to do something different. So, it's all somehow related, of course, but I want to start with a bug today. So, yeah, let me just show you. So, we have a bug. Let me just hide everything here. Nothing is interesting. So, basically, I will write a simple main function. And so basically, if we have an object, for example, I'm using StringView for testing. Oh well, let's not use StringView. I'm just going to write a small test class, so a struct basically, which just prints in its constructor. Let's just print constructor on constructor, if I could spell it correctly, and also introduce a little destructor, which prints. So, and let's just create an instance of this class. So let's do test, and let's log print. Yeah, our instance. So of course we now need a logger. Let's this. And now I would let's just yeah, so let's just log our instance with the constant string test. So now I can log my test instance. And of course I would expect that no copy is performed, since yeah, well, the logger is defined in a way that I would think that it captures values by reference. But unfortunately, so let's just run it and see what happens. Okay. Let's retry. So in this case, everything works fine. But if I don't pass my instance as the first argument to debug log, for example, I just print another string before test. Then my value gets copied. I don't want this. So, and I was looking in how to do this, and I actually came across the solution. So C++, I didn't know this, since I would have expected that the parameter tag, so let's find this, since this, I thought that a type parameter tag abstracts over an arbitrary, a list of arbitrary types, including the type modifier such as const and reference. But this doesn't seem to be the case. So the solution is really simple. I just got to add const reference here. So I just googled just what I was trying to do. So something like something like this. And well, I clicked on a solution previously, and here it basically explains it really good. So some dude actually explained it quite well for me. And yeah, the solution works perfect if you just add a const ref before your parameter pack arguments. So I've done that now, but I didn't try it out actually. And then and the person also said that I had to move the arguments to achieve perfect forwarding. So let's try this as well. So of course, then I have to include utility. And then let's also forward. First of all, does it compile? And we have to forward this as well. So now I can't print. So I'm not really sure what the problem is, but I'm just going to specify the type here as well. Should work now. Maybe I have to let's just drop some types in. Oh. So what's her problem now? Yeah. So somehow printing single characters don't work. So no matching call to forward. Const char would lose const qualifier. Yeah, so then does it as a const? And I just, well, it is a const reference. So what happens? What is the problem? It can't print a single character. Why? Okay. But I'm passing it along, so explicitly specifying the whole signature. I do this. I wonder. I have group types. Const char to well. So what happens if I actually clean this a little bit up? So maybe let's just try it out. I have basically my idea was to specialize the logger for this type, but let's only use base types here without the type modifiers like const and pointer, the type constructors like those. So maybe the problem can be solved if I pack logger implementation for that work with a character together. Does this help? Because then I can just ask for the logger of type T. Well, what did I do here? And then I should just be able to forward this. Okay. Yeah, so of course this now belongs to this class. Character. So it can't find a implementation, the logger implementation. So if I have a const char value, but it sees a const, doesn't it? What is the problem? So what does not work? I can't pass a character, value character. So let's just copy paste the whole thing. Let's just say that this is allowed, but I think I already tried this. Enable if. So basically, if our T is not a reference, then this overload shall be enabled. Does this work? So in this case, of course, I just have to pass the value. So this doesn't work either. What is this problem? Can't cast const char. But what is its problem? So this doesn't seem to be a solution. So let's try to work around this problem. So let's just use a string view. To print our value. Just constructed a fixed character pointing to this character and the length 1. So this should do the trick. Well, but it works specified. So we set the string view. So maybe I have to go back to my Google search. What is different? Perfect forwarding. Already Googled this. So in here we only have, well, this is German. I don't want to read German. Oh, let's see. Why can't it pass it? What is the problem? Do I actually have to this? So I actually want forwarding reference tags for the value. Oh, it builds. Perfect. First try. So now we only get one print. So I was struggling through this. So we don't need these horrible things. Oh, but I actually hate it really much. Well, look at this. You have to repeat the same structure everywhere with slight variations. So we have a different type here and here, but the other other structure is completely the same. So this problem doesn't occur anymore, but so we tried out, so we rewrote this to fix a previous bug, but well, I'm just going to revert this, test it out if this also works. So let's just use a helper method, which is just going to take first argument. So in this case, I think we're also using the perfect forwarding thing. How is this called? Oh, let's learn some C++, shall we? Yeah. Accept the cookies. Oh, no, doesn't help me. Oh, this one. R value. Okay, fine. Sure. R value reference. So, and then I can just yoink some code from here, just use the T and forward this to my concrete Locker implementation for this type. And now I think I'm able to collapse those into one case. So in this case, I'm just going to accept the parameter pack, and then just going to call log1 1, and and the whole thing. So like this. So this is really basic. The structure now is really basic. So this just expands out the argument tag, and it forwards the individual arguments to calls of log1, and I would like to call this one log1, please. Log1. How does it work? I already see some problems over here. Log is not a member of. So do I need a specialized logger for this? Oh, advertised for this. So now try it. What if I give it a dummy implementation? Plate parameterized. Well, with a one parameter called count. Parameter. No, I can't say the word. Parameterized. Ah. Okay, but does it work now? So I know that this pointer decays just to a const char. I have to write this. No. This. Do I have to somewhere include the reference symbol? No. Because this type is really misleading. So logger. Ah, well. So what if we revert this a little bit? Something like this. Oh. So now we have, I think, even though I don't know if I have to specialize this here for every case, I would like to support, but let's just try this out. So now, but now I don't have to inline this into the general log function. So in those cases, we just consider a single case, a single dispatch to our logger. So I think now it builds, finally. Oh, and how many copies do we have? Okay, no copy. But can we still log everything else? So let's try a number, a space. Maybe the space is a single character. So distinct types, fields. So now I'm happy, basically. Works perfect. Whew. So this logger was quite some pain, but well, it seems to work. So I thought someone was at my door, but this wasn't the case. So we have another problem we worked around. So let's look at charset again. Just saw this. So can I just log single characters now? Can we also include this in our capabilities? So I think we can. So now charset. Well, we remove the changes. Didn't CLion flush the changes to disk? Hello? Ah, yeah, okay. So, and now also I should be able to do the following. I'm just going to remove the test I wrote today, and I'm just going to rerun the code from last time. And before I do so, I'm reverting implementation, which caused a crash because because of our broken our logger that was broken. So because it also copied classes which were subclassed. Of course, it isn't allowed to do, since then it destroys the basically the instance. So let's rerun the code, see if it still breaks, or if this fixed our problem. Works nice. Now it captures the instances by reference, so it passes them as reference to our logger, and this is exactly what we wanted. So this debug. Now I can also fix the I think logger of charset. How did I write this? Logger charset. Ah, yeah, I think maybe yeah. So let's double check. I do prefix it. So I think I'm using the similar pattern always. I'm here using the type without type constructors like const and pointer. So let's fix this here as well. So this type, we specialize it for the class, except the argument. We can accept the argument basically as a reference or as a pointer, for example, and then we would just add another overload here. So, but I think I also, yeah, so maybe let's first of all stage the changes. Yeah? And let's look through them as well again. Because I know that I introduced some wild code here. I remembered correctly. So let's remove this. Does it still build and run? actually doesn't work. Since I know what the problem was. So basically, this was a workaround of a previous problem. So I'm just going to use our logger now, print this value. I think it will work correctly now. So what did I print here? Automatons. So let's just run this code, which generates the automaton and prints it as well. I think it works, also works perfect. So basically today I fixed several problems. This is nice. So I don't need this change. I can just stage this again. So, and here, so this looks good. So now I did a previous commit, which already said something similar. So make really event copying values logger instantiation loggers. Let's just use simpler words. So perfect. So now our problem works again. Our problem works again, yeah. So our problem is fixed. So this was the bug I was talking about, and now I think I will now work on something fun. So basically I would like to produce some unit tests or yeah, something like this, and I just want to, well, I would like to test my parser, and for this it would be really cool if I just have something like debug show. I can pass the same values as I would pass to debug log, but instead of printing this, I would like to create a string. So yeah, basically something like this. Of course, this variable isn't defined here, but just to demonstrate, maybe let's build an example that we can then work on. So I will just rename our main again, create a new main. Let's debug print like character, maybe like this. Yeah, maybe just like this. And then I would like to have a string. So, but we currently only support string views, which are read-only just a pointer and a size to arbitrary bytes, basically, which you then can print out. But this has to allocate a string. Since yeah, this string. So I don't know how big the string should be. So I have to create this one on the fly. So this is what I would like to do now, basically. So I'm not sure how I would like to do this. So I would, but so I don't know if I would like to have a mutable string. So let's sketch something out. I don't know if I want something like string and then have methods like append and the like on the string itself. I think I would like to externalize building the string, and then I just have a string value which is very similar very similar to string view, but also manages the memory it was constructed with. So what does our string view support? Basically some really simple operations. So I think I'm just going to copy string view for now. Can I jump to the folder on disk? Don't see it. Find. This one? No. Open. I found it. So, now what if we just copy the files and rename them to string? And then we're just going to add them here. So we have string view, and let's also add string. Also here. So, and a constructor basically have the following constructor. No, I don't want a constructor. Just an empty one. An empty one is fine, of course. This constructor will be private, and it will always, I think it will always take the ownership of the underlying data. So let's maybe write a line, take ownership. I think it is spelled correctly, yeah. So then we have similar accessors like we have in string view. But we do want a constructor which takes in a string view. So this one just calls the underlying constructor, and here we just accept a string view. So, and I think I will just forward declares. Oh no, I don't want to forward declare string view. So let's use absolute roots. Also, I copied this class, so I'm going to change it here too. So string. So, and also I would like to create a method I'm just going to call just view, I think, which is able to construct a view from a string, from any string. Oh. I think I would like to explicitly convert those two types. So of course we now need to also include implement a logger for string. Now I think we just have to implement some methods. What is, well, let's switch to string. And let's reuse the logger for string view. So let's just use our view that I have to include logging, call logging. So, and this takes a size different. So in this constructor, always size. So if data is not null, using size. So this constructor is private, so I'm always require a valid size. A null string is also possible constructor, of course. So now I also had a. What is your problem? So I think I have to include string view. And I have a string view constructor, which will just allocate, I think. Create a copy. So, and then, of course, what I'm missing, a destructor that is going to release the memory. So, all I use malloc free, like in good old days, or new and delete. Now I'm just going to call malloc with view.size. Can I access the size of this type? Can I use this syntax? Since our array accessor should return a character. So if we would like to change this in the future, I think we can just write something like this to always make sure that we have the correct element type. So, and then we, of course, this returns a pointer, and we assert that the pointer is not null. Pointer and malloc and null pointer. So, and in this case, we're just going to assign data to pointer and remember our size. Our size is view.size. What if we skip this variable? Can't it just implicitly cast in the So, and of course, the destructor should be really easy. If our data is not the null pointer, we just free it. Data. So, and we of course have to include the stdlib. No free? Still no free. But it doesn't want a constant pointer. I don't care. Let's do it. So now our strings should always so basically if I copy a string, now its fields just get copied. So I have to implement so I now think I have to implement copy constructor and copy assignment and things alike. So how did I do this in the list class? Yeah, I think I have helper methods copy here and consume. I think I'm going to steal this idea. Even though there could be a bug in my list code. So, and the idea is that for copy construction, I'm moving this out of line. I don't like this. Don't like to do this here. So I think it has. I don't like to see this since I'm not concerned with speed right now, and it has different levels of details. So this constructor is completely hidden, but this one implementation seems to be really important. Well, defined in the header. It's in the header, but just moving it out of line. So let's go back to string. So constructing an empty string or a string from a string view, which allocates internally. And I also would like to do, let's also friend a class called StringBuilder, which currently doesn't exist. But we will friend it and forward declare it the same in the same statement. So now let's define a copy constructor. Let's just add every kind of constructor we need. So we need the copy constructor, the move constructor, and of course we also need copy assignment. and move assignment. So let's implement those. So let's have a peek at list. I think I'm not really sure. So I think I'm going to steal the style of implementation. So this means that our copy constructor can be implemented the header. This is only a single single call to copy here. Oh no, not paste. And the move assignment is so the move constructor zoom is basically the same. But list, yeah, list does include a city move. Sure. Okay, cool. So those should be implemented. So this, of course, I have to implement the other methods as well. So let's add some. Yeah, sure. So to copy a value, we're first going to check we're copying into ourselves. If this is not equal to other, then we will copy, and we will always return a reference of ourselves. And the copy is just copy here other. Thinking that we're going to clear before we copy here. Similarly, we are going to check. Basically, we can copy paste this and just have to replace a single call. So we have to name the parameter, of course, and this one is consume. No, well, yeah, it is correct. And then we can std move other to consume. So now we have also position have been declared as no accept. So and clear will also be a private function for now. Just releases the internal memory. So I think so it actually could be public, but I don't think this is necessary. So let's implement clear, and now the destructor is really simple. We can just call clear there. So we're just going to move implementation to the header here. So now we only have to implement copy here and consume. So my IDE doesn't want to generate appropriate stubs, so I'm going to do it myself. So to copy a value here, we of course we're assuming that we constructed that we have a valid instance, and we're just going to allocate enough memory to copy the. So we're basically re-implementing this. Huh? Okay, don't want this. Can I somehow share this? Or maybe another overload. just takes a string view that so now I'm going to move this implementation, my private helper, of course, the default other here, and copy here, and now just refer to copy here with the view. So now I can move this to the header again. And this one can be called in our constructor. So in this constructor, so now let's do consume. To consume an instance, we're going to std exchange its data. So just std exchange using the other data and null pointer to clear the data of the other instance. Also similar its size. So we set its size to 0. This should be done. This should be it. So does it want? So I think we should be golden. So now we have a string. So let's try out if it works. Let's so our string view just create a text called hello world. Let's try it out. So let's define a string. So I think well string. I think I forgot something. Also do this. I'm doing all my types so that I can use it unqualified. So now let's comment this out. So now I should be able to now, I hope, allocates a string which has the same content as my string view. So of course this is my view. To work. Okay, I might error here. So let's. So I allocated memory, but I didn't copy anything. Let's have a look at our string class again. So we allocate memory, but we don't copy anything. So let's memcopy. Where's memcopy defined at? So we copy to data. We're copying from other data, and we are copying bytes. So let's check this one as a local variable. Call this byte count. Let's auto this. So memcopy. Where is it defined? It is defined in C-string. I think the problem is similar the problem which I already had. So I think I have the same problem here. So I'm keeping a const reference. I think I also want a mutable processor. I'm just going to const cast it. Let's see if this causes a problem in the future. So, what is your problem? Oh, let's data direct. Oh, well, I don't need this, of course. Good. And I can do the same. Oh, now I have to const cast this. Or const cast this. Or should I just remove this const qualifier here? Then just const cast it once. Also, string. This had work with this stuff. So we accept it as a const char pointer, but we are just going, so we are going to store it as a char pointer to a char characters. And now I'm going to const cast it once to a char pointer. Then I'm also going to add a mutable accessor. So now it doesn't link. The executable is still running. Okay, let's see what happens now. So now our string should still be valid, but now we also copied hello world. So of course, show some more data in the debugger, but our size is 13. So we actually allocated 13 bytes in this case. Okay, fine. So let's see if our logger works. So let's debug log our string. This should also work, of course. Yeah, yeah, it does work. Copy this. So let's do a copy, and let's do another copy, and let's just let this be const. Oh well, let's do it like this, and then let's do a move of B. Let's see if everything works. So let's look at the addresses. So let's skip this to here. So the addresses. So they are all different addresses, 13 characters. Yeah, looks good, I think. if I std move this, and this instance should go away. So that's step one step. This is the correct address. Was it the same? So let's pay a little more. Let's actually remember what this address is. So it is 19C0 and is 9C0. So it is the same address. So my move operators and my copy operators, copy assignment thing works. And since copy constructor, move constructor, and move assignment and copy assignment share their code, I'm going to assume that this works as intended. So now we have a string class. Let's see what we actually did. So I don't know. Well, let's just commit it together. So since the implementation of string, so since string and string views seem to be, they are comparable, of course. So I count the fix to string view to the implementation of string as well. So introduce class string. Heap allocated string that gets destroyed on. So let's keep it short. So let's reintroduce this method. How do I want to do this now? So I think I'm keeping this as a macro, but I also think I'm not calling this method debug show, but I think I'm going to call it different. But yeah, so now we have a basically a object that represents an arbitrary pointer, an arbitrary string. It could be loaded from a file, or it could be a constant. It doesn't matter. And this string is not heap allocated. But we also have a string which gets copied into a new memory area. But this is also a fixed size string. I don't think I will introduce append methods or something like this to this class. I will do this in a separate class. So let's do another class that I'm calling StringBuilder. And this class simply, first of all, let's set it up that it gets built. So a string view and a string builder. Oh, string builder, and also string builder here, down here, builder. So to resort it alphabetically, builder followed by view. So I basically have to sort those lines, then lists are again sorted alphabetically. So this. So our string builder, a string builder. Let's also put it into our core namespace, of course. Of was brilliant pun. Yeah, sorry for that. So I think I am going to let's do this. Every string builder will get every string builder will get inline capacity, I think. So we are just going to store the first characters inside of the inline buffer. We store the first, I don't know, let's say 4069 characters in our buffer itself. After that, we will expand to well, we could use a list for this. We can just use a list for this. I think we will do this. Oh, I think I will just use a list internally, but I will store the list itself in the inline buffer. So I'm just going to experiment a little bit. So let's do a small which is just going to help me to differentiate if I'm using the inline buffer or the heap buffer. And of course, I have to include core types. Get my type alias. Okay. So I think then I can just default this constructor. So and I'm going to initialize this as inline, since the first couple of bytes will be stored there. So because now let's do a append for a character. Let's do the base. Let's do base types here. Which base types I'm supporting in my logging? Let's move those. Those basic types I should also go. So I'm going to support those here. So just going to copy those methods here and use them as a list of things I have to consider. So I would like to append characters. I would like to append sigils. So let's give const stars. Let's add them. Changing my mind. So, and then of course all the signed integer types, unsigned integer types. So I can do some magic here, some editor magic. and let's define them all at once. Also, I would like to be able to append a string directly. Of course, this implementation just append using other.view. So basically, a string builder will include almost every string type, and then after appending all my values, I would like to do a string to string. This one allocates a new string if necessary, clears the string builder's memory. And I'm just going, I think I'm going to internally, well, let's just see how we do this. So let's implement some methods, shall we? So I'm going to start with my, I'm just going to add all stubs. So let's first define a namespace. So to append a value, I'm just going to create an anonymous string view. I give it the value and fixed size. So and then let's just use the append method for string views internally. So we could also do this in the constructor. How will it look? So looks okay. And this one can also be done in the constructor by delegating to the string view constructor. So string view I have to implement, of course, and I think those I have to implement. So those, but also string view. So let's start by implementing our string view. Oh, well, let's do this last, I suppose. Is this? So let's reopen logging here. So I think I can generalize a lot of things, but let's actually see what we have to do here. So I would like to open this one. Oh, okay. Let's start. I think I can print this by using sprintf. I'm just using how to do this. I think I'm creating a helper method which will be not visible in the class, and I'm calling this one append. using sprintf. So, and I would like to do something like this. I would like to call and using sprintf. Of course, I have to pass in a mutable reference of myself. I have to pass in the value and the format specifier. And for a signed 8-bit, this I'm just going to steal it from here. So in this one, this method, well, let's just call it impl. A stupid name, but a little bit shorter. So string. So let's accept a string builder as a string builder. Then value. So I'm always passing it by value in this case, and the format specifier. Empty. Then I will templatize this by. So now I should be able to create a buffer. The buffer. Can I somehow find out how many bytes I need? So let's say, let's just fill out every call. So, and here I want to just switch out the size. $32, $46, no, $64, of course. So, and here I'm using unsigned, so I have to do here. So, and let's do this early. Load. So I think I would like to express this way. So why does this break, but this doesn't? But not yeah. So basically, now I want to do something like where's printf defined. I think it's from stdio. Printf. So let's read what I can use. So this one, I would like to give it a max size. This one is fine, but where? Oh, stack API. I don't know. This is sprintf size. Is that such a thing? SN printf. This is what I'm looking for. SN printf. Yeah, exactly. I give it a stream, a size, and a format string, and then the arguments. This is what I would like to use. So using this, and it returns the number of characters written. F. And printf. SN printf. So what does it return? Number of characters not including the terminating null character, which is always written. Negative if an error occurred. So let's just allocate a small buffer on the stack. Or let's actually use, I don't know, like let's don't use a too small buffer. Let's don't is sounds really wrong. So let's say big enough buffer, and then I can give it the buffer and of course the size of our buffer, and I will give it our format specifier and our value. And now count. Let's just assert that count is actually so basically let's just assert that this number is non-zero. It always writes the runtime constraints. Yeah, I think this should be fine. Now I can just use now I can just create a string view with the buffer and the count. And then I'm just going to builder append using our temporary buffer. Then it gets destroyed and it is not allocated on the heap, located here. Then it gets destroyed and only have to implement this method. This should handle everything. So let's see how we can do this. So to append a string view, everything falls back to this method, which I quite like. So we get a view. We would like to So now I would like to do something like the following. I would like to do I would like to do something like this. I would like to get a character and it takes in, so I would like to get a write allocation which has space for let's use a really explicit name here, and I'm going to give it a StringBuilder and a count. A U64-bit integer, I'm calling count. So, and the idea is that this method maybe it should be a method since it has to access members. So let's make it a private method. Write location with space for byte count. Let's call this argument byte count. And it is a method, so I don't need to pass this along. So the idea is that so I need to store the used capacity. So I have to store the capacity. So let's do this. Expr static auto inline capacity. So let's declare this value as a constant. We can use it here, and then we can say, well, we have capacity. Our capacity, since we're using the inline capacity first, inline capacity bytes, and our size is 0. So now we can ask. So basically we will delegate to this method. This one will just, so the idea is I will get the location. I will get the writable location with space for view size bytes. This points to a position where I can just write into this. Then I will memcopy into location view.data and view.size bytes. I think I will do this, and then I can just do std. Now memcopy is string. Yeah. So, and now of course I only have to implement this method. This method will do the following. If we look at this flag, so let's do the base case, the easiest. If our byte count, if our size plus the byte count is greater than our capacity, then we have to allocate. So the base case would be to convert this. So this less or equal to, we could just give out our but this depends, of course. So we also have to switch about our and have to look how we initialized our object. So if we're using inline memory, we're just going to return memory storage of our position. So this current size. We return this as a pointer, and we're using our heap. So this one will be fun. I think this is a little bit too complicated, I think. Can I do it a little bit different? So let's say, let's keep a pointer I'm calling data. Let's simplify this a bit. But I want to keep this with the inline capacity. So, but our pointer will start will point to storage. So this way, I think, generalize this. So I can a little bit easier here. So I'm just going to return the storage. So if we don't have enough space, this means we have to grow. but we have to grow differently if we are coming from the inline storage. We are transitioning into it. So we'd never transition in. So basically now we can just let's do switch. We are looking at where we currently at. If we're using inline memory, we have to allocate. So let's grow by 2. Let's grow the capacity by 2. Oh. Do you want to be in video? No? Oh, the cat came to visit. Oh, but now if we are using the old capacity, now while capacity is smaller than this amount, we're going to we double our capacity. And then we are using the new capacity as a target size. So if we are transitioning from our storage into memory, we are allocating some bytes. And then we are, so know that we can just, so of course we have to set our memory to heap, but we also have to copy the data. So memcopy to our newly allocated thing. We're copying from our storage, and we are copying the whole storage. So now we have enough space. Now I can do this. So I think I can do this in all cases. So I think I can then just reverse this condition again. So like this. So now this code, we have a single return. Just going to break here again. So if we are using, if you already use the heap, we're just going to realloc. We're giving it the old data and our new capacity. We don't need to copy anything. We are still in our heap. This one is also valid. So the size stays the same, but we of course have to use the new capacity as our new value. So we're going to set this in all cases. Yeah, so I think this should be fine. This gets a writable location with enough space to write byte count bytes. So now using the method, the last method. So we are turning our string builder to a string. we have to differentiate two cases. But we can, yeah, so if we only used our internal storage, we're going to have to allocate a new string. So then we're going to construct a new string. We are going to construct a new string by giving it a string view, pointing to our storage using our size. So in this case, we are temporarily wrapping our, I think I need to cast this, a 64-bit integer. So we are temporarily constructing a new string view, which points to our internal storage, and the string constructor will allocate enough memory to hold this string. Then we can just return our string. And of course, we have to reset our size. So since toString will nuke the memory and reset our buffer. So, but if we don't have, if we're not using, so I think I have to do some scopes. We're defining a variable in our switch case. So, and if we are using our a string which was allocated on the heap, we just use the data. So we give our string the memory. We give it directly, so we don't need to allocate anything. So we use the private string constructor, which we can use since we are a string builder. So we are class string builder. Then I can just reset our size and also reset data to storage, and I can also reset the flag. So the next time we would add something to the string builder again, we would use our inline memory again. So I think this should work. Let's test it. Oh. Another typo. So now I can append, for example, let's start by appending a number. Let's see what happens. So I saw a warning flow. So there was a warning flying by. I didn't see it fast enough. I somehow go back to the warning. Yeah. Did I forget to do something? Yeah, I think I forgot a default case. Let's just assert that we don't reach here. False and unreachable. And let's return a null string. So let's rerun. So let's see, we have a new StringBuilder. We have a inline capacity. We are currently writing in our inline capacity. And we have some storage here. And we should point to our storage. So let's see what append does. So append calls into here, and then we should call into our implementation. Allocate a buffer on the stack. And we use snprint, print to the buffer. So what does the buffer say? So 5, 3. Yeah, see, our count is 2, so we wrote 2 characters. So then we construct a temporary string view, which points to 5, 3 and with size 2. So this is. Then we jump into our append method. Just delegates to right location with space 4, writable location with space 4, and then jump there. Okay, we jump there. That's more space. So we want to write 2 bytes. So then we just, I forgot the thing, but so we have enough space. We have still 4,000 bytes, 4,096 bytes to write. We currently haven't wrote anything, and we want to just write 2 more bytes. So we don't have to grow. So we're just returning this location. And then we are copying our 2 bytes into it. Oh, and then I forgot to implement our size. This was obviously wrong, but problem. So let's redo this. So the cat Bernhard sitting behind me. I don't know if you can see him. No, camera points too high, sorry. So let's follow the call chain again. We're using this method. Already looked at this. We're appending this. So we should get a writable location. We copy the value into it and advance our size. Then we return. Then we have a StringBuilder which has 5.3 into its written into its internal storage. Okay, it seems to work. But now let's change how the internal storage, the size of the internal storage, just for testing. So we are using, I just use let's use 5 for testing. And then let's add a string called, let's space hello world. Keep it simple. Let's see what it does. So this one should work as intended. Now I will look how this one works. So we all delegate to our append method. So now we should grow. So we see we have an inline capacity of 5. So our current capacity is I see 5. Okay, should be fine. Our current capacity is 5. We already wrote 53. But now we don't have enough space to write 15 more characters, so we should allocate. So we double our capacity as long as we have enough space to write 15 more characters. So now we are using inline, we are currently using inline memory. So we should malloc enough space for 20 bytes. Then we copy everything into data, and remember we actually use the heap. And our capacity then, we have to update our capacity as well. Then we have enough space to write 15 more characters. We do so, advance our size. Now it should be good. And so, but now the storage, why does the storage contain H and not be the case? I'm returning storage of size. I see, I should return data of size. So because we initialized the data field with, okay, we were using data, initializing it using the storage field, but I should always return data of m size. Okay, sure. So let's just restart. So this one should work fine. We are delegating to StringView constructor, and then let's skip this a little bit ahead. So now we're returning a writable position. Copy into it. Let's see what this actually happens. So our storage just contains 5 and 3. So we don't clear the data or something like this, but we allocate space at a different address, which now contains 53 hello world and a line break. So and now we know we have 2 characters, then our size is advanced. We have space for 3 more characters. Then we return, and everything is fine. Perfect. So currently we can't move a string builder. Let's for now disable copy. Just noticed, let's just delete this constructor. And also let's just delete our move constructor. Maybe just for now, since I don't want to implement them right now. And so then we should get a compile error. Also the copy assignment, the move assignment operator. So yeah, this should be fine. So and then let's also test growing. Let's also test growing our string builder from heap. Also from spec. Also hello. Let's just print a garbage string with maybe a rocket emoji. So I have to type it in German since Windows, I don't know why, but Windows Windows translates smiley descriptions. So let's just restart and see what happens. So the first worked. So then let's see if we can grow again. I think so, but Let's see. So let's jump into it. Jump into here. Oh, let's restart. I jumped one step too far. So let's be a little bit more careful. So jump into here. Jump into here, but this is the string constructor. Jump into here. Jump here. Jump into here. Yeah. So now it works. So we haven't enough space to write 24 more bytes since our capacity is only 20. And of course 17 plus 24 is greater than 20. So then we double our capacity, which is currently 20. I think we should double it 2 times. So our new capacity should be 80, since if we double it once, well, maybe once should be. No, we double it twice. Since our old capacity was 20, 20 was less than. I think we have to do a less than or equal here, but it doesn't really matter. So 20 was less than 17 plus 24. Ah, yeah, so I see. We have to double twice. 40 isn't enough to store the result. 24 plus 17 is 41. So we have to. No, should be fine. Should be correct. So 41. So, and of course 41 doesn't fit into 40. So we have to double again. So we get a capacity of 80. So this is correct. And then we're just going to realloc. And then we update our capacity, return the writable location, write into it, also hello space. Ah, yeah, so we point here, so perfect. So we wrote here. So our data should contain all the strings, and then we also update our position, our size, done. So now our string should contain hello world, also hello space, and then the rocket emoji, which this should be like given by this character sequence, but I don't. I think it worked, but I'm not going to double check. And then a line break, and this should be it. Perfect. Let's just remove this for now. So building a string works, and now let's export it as a string and let's call it like X. Really descriptive names. So first of all, we have to move this. So let's try. So our string should now be constructed. Let's look at how this works. We jump into it. So we have heap memory. So we're just yoinking the allocated memory out of our string builder, giving it directly to string. So now string should contain this memory address, so 940. This is the same memory address which is here, so 940. We're resetting size of the string builder, resetting the data field. Now it points to our inline memory again, and we're resetting the inline flag. So now we are copying. No, I hope we are moving the string out. Yeah, it calls the move constructor. It destroys this string. Ah, I see. So we have to. How do we do this? So this constructs string has a destructor which always clears the value, but we don't differentiate we use this structure or not. So we're not allowed to clear all the time. We only have to free the memory. We're only allowed to free the memory. Well, it should be 0, shouldn't it? So let's go back. So this turn should have removed this string, should have moved this. I don't expect any error. So now we have a string, which points to the same memory, which previously was owned by StringBuilder, but now it is owned by the string instance. So now ours should be destroyed. So string clear, let's follow this call. Data is not null, so we're going to free memory. Perfect. I think it works. It works. So now, of course, we also have to add a destructor for our string builder. So, and to destroy our string builder, we're just going to switch on our memory, and basically only, so if we're using inline memory, it's fine, but if we're using heap allocated memory, we're just going to if data, well, we have a pointer, so we're using heap memory which is all allocated on the heap, we're just going to free it, I suppose. Free. So perfect. And what I wanted to do is after malloc and realloc, we're just going to assert that we actually get a pointer. And also for realloc. Okay, so now we also be able to destroy a string builder, but it of course only freezes memory if we own memory. So I think I like my string builder pretty. So I like that we have inline memory, inline storage, and it could also be a template argument, but I don't want to do this. I think like 4096 should be enough for now. And of course it grow, but doesn't need to grow. So and now I can just append values, and first of all it just only allocate once. If we are using inline storage, to move it into a heap which is allocated on the string, string which is going to allocate one string in the heap. And if we grow out of our inline storage, we just yoinking this memory and stealing it, and StringBuilder delegates, gives the ownership to the string and just resets its internal state. So I think this is quite elegant, exactly how I would like to implement my StringBuilder. So let's commit it, and then let's do some fun. So would you StringBuilder the first couple of characters First, let's say the count characters are printed into line storage, and after that throw a string on the heap is allocated. This reduces allocations. Well, actually we could always allocate, and then we could always allocate a string and let we could always steal the memories, but let's keep it this way. Maybe we will simplify it later. So let's keep it like this. So now, what I dislike that our where do we have it? Our string builder has append methods for all the primitive loggers, which I'm defining here. So I think I'm just going to nuke some loggers. Just going to, well, let's just, what if our logging renamed, our logger is renamed to format? I think we should be able to use it for logging and for formatting, so constructing a string. So let's rename this to formatter. And then let's move the basic formatters out of the way. How should I define those primitive formatters? I think I'm going to move those, since we always need to know those, to the formatter class. So I'm just going to define them here. Of course, then I have to include core types. Yeah, but it should be fine. So then I can this up formatter. So now let's add a class formatter. Just create this file and just create a file. Ridiculous. So let's just copy this to formatter cpp. So then include formatter namespace for. So now I can just join those here. So logging, I don't need the logging.h.cpp class anymore. Formatter, now I have to formatter.cpp file, and the logging, I didn't name it here, so yeah, forgot a closing parenthesis, should be fine. So printf, I have to re-include stdio, include io. Now it should build again. I hope. Yeah, okay. So the logger constructs a formatter. So now the formatter always create a string. So the method signature I'm expecting for my formatters always get passed in StringBuilder. So let's include this in the header, StringBuilder. I see. I have to forward declare. And StringBuilder includes StringView and StringView, and those already define a specialization for formatter. So let's just forward declare it. Then let's do some refactoring. And pass StringBuilder as a first argument. And of course, the method log doesn't fit anymore. So let's rename void log to void format. Then we should be fine if we just search and replace. So of course I have to change every appearance of log here as well. So let's rename log to format. Okay. Then I have to pass in the builder, builder. So now I just have to include StringBuilder. And I think now we're just delegating to our append method. Does it build? should not build. Yeah, it doesn't. Perfect. So of course it's not perfect, but yeah, I expected this. So now we want to log. We're just going to create a new. So someone at the door. But I don't want to go. So then we create a new string builder. So this name doesn't fit anymore, login.h. I will rename this last. So basically this class just going to call this format. Let's do it now. So I'm going to call this one formatting. And I will call this one format. And I will pass in a string builder. I will also forward it here. I hope this works. I will format it here, and I will also forward it here. I will pass it here. Oh, paste it at the wrong position. Then pasting. So now this one, just the overall format implementation. And this is the one I'm going to use everywhere. And then we have a debug log. So I think our formatting should also include StringBuilder. We require here. Then we are just going to pass the builder here as well. So and then we have a string, and then yeah, so then let's just create the string. So builder to string. And then we're going to log it. So and I'm going to use, so how do we print this? So we are always printing using, let's just, I think I'm going to do the following. I'm going to construct a view out of the string, just going to say view.print std out. Let's say for now something like this. Well, I could also just include this. I could do it here. So let's do it here. I would just printf a string, but with a size. So I think this was the syntax. So view data view size, cast it as a integer. So this should be it. So, but now would like, this one is the method I'm calling from everywhere, but I also would like to do something like this. I will do an overload. Let's call this one format into, changing my mind. Format into, and this one just format. This one will do the work for us. So we'll basically do this. So we're just going to create a new string builder, format to the builder, and use this, the forward syntax, perfect forwarding. And then we will toString it and then just return it. So, and format into is just getting called. Yeah. Okay. So now debug log will now use formatting format. Just pass in the arguments. And this already returns a string. So something like this. Clean this up. So yeah. So now we have a view printed done. Yes, gets destructed. So, but now what I can also do, I can just say define show. Let's say compose, I think. I would like to call it in a similar way, but I just want to delegate to this. Just this. So now I can use debug log to directly print to the std out for now, at least, and compose will just return the string. So I could also call this one directly, but I like this shorter name. And compose, of course, will compose a string. So by now do like 42 space hello, if this works. Somewhere I'm calling a method which is called log. This one should be format1. So I'm just renaming some methods. Match our new naming scheme. Let's try to compile. Or it doesn't work. Everywhere I'm calling. So I have a formatter here. So now the formatter requires a string builder. Our string builder gets passed in everywhere. So string builder. So and this one is called format into. Your problem? So yeah, okay. So now I have to fix every method basically. So it tries string view. Yeah, so basically I have to look through all occurrences of this. somehow expected more. So let's accept the StringBuilder, rename the method to format StringBuilder accepted by reference. So now I can also optimize this. I'm just going to append this. Since I have a specialization for now, so I have to include StringBuilder. Oh, but why does it cry now? Builder string view. Method called format now. So formatting log. This one is now also called format. And it accepts a string builder. And also this method and this method accept this as a first argument. And I'm just going to format into B. So formatting log. Also I do here logging the automaton. Then I'm just adding a line break. What does so this is a little bit messy. So I'm just going to do this manually. I'm going to create a builder and I'm just going to pass it automaton log and also pass it here. Builder, and then I'm just let's debug log builder to string. So it's a little bit redundant. For this one, I don't end. Oh, it's a little bit hacky, but let's for this. This method should also be called format now. So format into So let's pass the StringBuilder everywhere here. Log into here. I forget to I got this. One member named formatter. I don't have a formatter for have formatter of let's search instead void log again. So no got to it. Methods again. Have to in this log method. Oh, I thought I searched for those. Let's search everywhere. I have small. So for format, gets a builder. Oh, just do this every. And why is explaining? I don't understand. But regex adjusted. So let's see. Try to recompile again. Could get some more errors. So, oh yeah, I see what the problem is. So basically, in formatting, I'm just going to include stdio for now, that we see printf everywhere we use the debug log macro. Maybe we'll put this into a different header later, but yeah. So log into, it's called format into. So this was dumb. Let's just rename it. We try. So of course now this method has to be renamed. StringBuilder. Now I just can search and replace. Log. Like this, replace. Oh, let's got this. And this called format in course. now every compile error go away. So I think I have one more method to fix. Here, specification, format, and StringBuilder. I'm going to add it here too. Format. Oh, well, what was this? Format. Format into, let's format into builder B. Builder B. Here, format into B and format to B. So I think now we should compiling again. I hope it works. So it would be really great since now we just have one concept and can reuse it for multiples. So let's see. We composed a string. We should now have a string out of 42 space and hello. 42 space hello. 8 characters. Correct. So we have 42 space and hello has 5 letters. So I think it works. So this is really great. Since now, yeah, basically one concept for 2 use cases. So I can now just create a string using the same mechanism as printing it. This is perfect. So because now I could do something like this. For example, I could write a function that parses string and checks for its error message. For example, so I don't really have a great example, but now we can start working on unit tests for our regex parser. I know what I wanted to do. Yeah. I remember. So basically, what I now should be able to do. Let's resurrect this main. So if I run this, it basically just prints out the regex structure of the regular. Oh, and I have a crash. Segmentation fault. Yeah. I think I get it. So in debug log, of course, I have to pass the size first. So let's try again. So because it now prints the structure of the past regular expression, just something here, so hello cat, doesn't really matter. So now I could do something like, wait, I suppose, parse regex. Gets a regular expression as a string view. No, not a QString view, but a string view. A pattern or regex. It just does the following thing. It constructs a parser, parses it, just, let's just throwing some code. Just initializing a regex parser. We're initializing, we are using it to parse our pattern, and we have an error. We're just printing the let's print parse error colon, then the error code that the parser returned. Let's remove the line break. Let's not debug print, but use compose. And otherwise, we have a regular expression, a pointer to a regular expression tree. In this case, we're just going to compose the regex. What this, of course, does, it uses the regex's format function. Just uses this to build a string out of it. So in all cases, I get a value, a string allocated on the heap. Now I should be able to define a test, like so. So now I can pass, for example, a easy character, so just the regular expression a. Then I could compare it. I think I don't have a comparison operator, but let's just say and expected. So let's define this as a string view. What do I expect? I expect the string atom, single quote a. So this is the expected result. So now, and of course I could automate this, and I'm going to do this. So what did I do wrong? So multiple mains. Sure. Just try. Oh, and now I get a string which our parser or regex parser returned, and it is of course atom, open parentheses, single quote a, and basically it is the same as our expected string. It has the same length and of course the same string. The string is the same in the first 9 characters. So, but I'm just going to leave it as is now, and we're going to automate this process later. But now, same mechanism for printing and same mechanism for creating strings to format. I quite love it. We could change quite a few things. So now I will commit. Let's see what we changed. So we touched a lot of things, but I'm just going to add everything. So I dislike CMake. So this I renamed. Of course, I had to change every format. Let's just peek into the classes. Yeah, so this is a hack. Parser. So we're just changing the include. So I think this is looking good. So this is now, what did we do? We generalized logging and formatting. Always create temporary string, and this can print it out. Formatting and printing have a similar API, which bears a lot of code their implementation internally. Not perfect, but understandable. So this was quite fun. So we did great progress today. I'm really happy. And of course, nothing is perfect, but today we built a string class which holds a heap allocated string, built a StringBuilder, which constructs strings. Basically, strings and string views are the same, except that string view doesn't own memory. String does. StringBuilder is used to build strings. And then we generalized our formatter, which was previously called logger, to always build a temporary string. So every logger, which is now called formatter, gets passed in a StringBuilder as their first argument. And in their implementation, they just append the value to the StringBuilder. And to construct a string, to log a string, we're just going to create a temporary string and print it. So this step is actually unnecessary, but I'm going to keep it. Just saw another thing, but doesn't matter really. And to compose a string, which is just to build a formatted version of a string, we're just using the same code internally. So we have here the same call as here. And yeah, of course, here we build a string which is then used to print, and our compose macro just calls format. So we also, of course, could always call formatting.format, so colon format. But well, let's see if I actually like this using the macro. I think I'm going to replace it by this code. But yeah, we will see. I'm leaving it as is for now. So this was fun. So thanks for watching. Have a great day. Bye.